Let's take a look at an example of how to calculate density. The first thing we want to do is take a look at our diagram. This diagram has two different boxes, each with the same volume. They're both 9 centimeters cubed, and each box has molecules in them, each with a mass of 1 gram. So the first step we want to do is we want to see how much mass is in each side. So on the left side, we have 1, 2, 3 molecules, which is equal to 3 grams. On the right, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 molecules, which is equivalent to 9 grams. The next step is to write out your density equation. So step 1 says to write out D equals M over V, and it's kind of already done for me on this slide. The next step is to plug in your values. So we're going to write D equals, and on top we need the mass, which is on the left side. It was 3 grams, and our volume on both sides is 9 centimeters cubed. And then we would do the division of 3 divided by 9, which is 0.33, repeating grams per centimeter cubed. The units are important. They cannot cancel out because they are not the same. Mass is in grams, which is the G, and volume is in centimeters cubed or milliliters. Since they are not the same, they cannot cancel out. So density is a ratio of grams per centimeter cubed. Let's take a look at the second example on the right. D equals M over V. That's step 1. Step 2, we're going to plug in our values. So our mass was 9 grams and our volume was 9 centimeters cubed. I think this one's pretty easy. 9 divided by 9 would be 1 gram per centimeter cubed. Second step is we want to look at which one is more dense. So the denser one is the one on the right because the number is higher. Another clue is if you look at this diagram up here, there's very little space between your molecules, so it's densely packed, versus the one that has a density of 0.33. If you look up here, there's a lot of space between those molecules, so the density is a lot less. That sums it up. That's how you solve for density using this first example.